All right, welcome to our video on continuity. So I think if you think about the word continuous, it means, it keeps going. There's no breaks. It's um, if you think about like continuous in terms of like a road, you can continue traveling on that road without any problems. If there's all of a sudden an earthquake and there's a big hole in the middle of the road, it's no longer continuous because you can't travel through it. If for some reason, you're encountering a flood and now all of a sudden there's a huge amount of water in the middle of the road, it's no longer continuous. There's something that's keeping you from staying on that road. And that's really what's happening when we talk about continuity with functions. Mathematically, we define it a little more specifically, but intuitively, you can probably tell just by looking at a graph if it's continuous. So we want to talk mathematically about the definition of continuity, and there's three conditions that must be met. The first condition is that if you were to find the value of the function at that particular c, then it actually is defined. There's an actual output. So for some value c, we get an output. And then if we look at the limit as x approaches c, now notice this is not the one-sided limit. This is the limit as x approaches c overall. So your left and right side limits need to be the same in order for this to be true. So the limit as x approaches c for that function would have to just exist. It has to have a value that you can kind of make an educated guess about. And then really what number 3 is saying is that 1 and 2 are the same number. So the same value that you get when you plug in c is going to be the value you get when you find the limit. As long as those three conditions are met, you have continuity. And we consider a function to be everywhere continuous if there's no breaks in that graph at all. But you may have a function that's only continuous on a certain interval. So maybe between -10 and +10 for x on that particular domain, your function is continuous. But maybe there's something that happens outside of that that makes that function not continuous. Then you would talk about that particular interval for discontinuity. So graphically, we're going to look at these, and I think you can probably tell just by looking at the graph whether it's going to be continuous or not, but we're going to actually try to figure out which one of those three conditions is not being met. What's failing in order for us to be able to claim that this is a continuous graph. So on our first function, what we're doing is we're looking at this particular point. We're saying at x equals c, is the function continuous? We're not concerned about anywhere else. Okay, we're just concerned about when x equals c, are we continuous? So what I can do is I can do three things. I'm going to check to see that f of c is defined, meaning if I plug in c into my function, I would get an output. Or looking at the graph, at x equals c, I have a closed circle. So those are two things that we're looking at there. So when I look at this graph, at x equals c, I have an open circle. So right away, I'm going to say that this is not a continuous function because, and I'm going to give a reason here, since f of 0 is undefined. Okay, it's an open circle, and I'll even put that in parentheses here. It's an open circle. So we know that this function is undefined when x equals c. Therefore, it's not continuous. Okay, let's try the second one here. So looking at the second one, the first thing I ask myself, is f of c defined? In other words, is there a closed circle somewhere when x equals c? So when x equals c, there's an open circle here, but there is a closed circle here. So we do have that first condition is met. It's good. Next up, we're going to ask ourselves, does the limit as x approaches c exist? So in this case, I would say if I look at the left side limit, it looks like I would have a different guess for my output than if I looked at the right side limit. My left and right side limits are not the same, which means my overall limit does not exist. So I would say that this is not continuous because, or since, the limit as x approaches c of our function does not exist. Okay, now the third graph, let's talk about what we're seeing here. So I have to check all three conditions, and I'm always going to do them in this order. First of all, does f of c exist? In other words, or is defined. F of c, do I have a closed circle? Yes, I do. So the first condition is met, it's defined. The second condition is, does the limit exist? Now remember, the limit is our best guess about what the output would be when we reach C. So I like to actually show you in class, take your pencil and lay it over top of x equals C. So if this is what I was actually seeing, and I said, okay, without actually knowing what's happening at x equals c, would I be able to make a guess about what my output might be when x equals c? And looking at this, yeah, I could. Whatever this y value is, like right here, I don't actually know what that is, but that's what I would call my limit, okay? So the first two conditions are met, but, so let's actually give this a name here, okay? We'll call this 5, and then we'll say, let me move that out of the way. We'll call this point down here where we have a closed circle, we'll call that 3. All right. Now, our limit, so for our first qualification, f of c equals 3. For our second condition, the limit as x approaches c of f of x, we said is going to be 5. The third qualification, in order to say that it's continuous, is that those two things that we just wrote have to be the same thing. So because f of c is not the same as the limit as x approaches c of f of x, this is not continuous. All right, and it's not continuous because that third condition failed. Okay, let's move on. So we've created sort of a checklist for you to use when you're trying to determine if a graph is continuous at a specific point. So you're just going to kind of go through this checklist, fill in the blanks, and it's going to help kind of walk you through determining continuity. So first of all, we're looking at the graph. We're trying to determine if the graph is continuous at x equals -4. So that's right here. Now, intuitively, you'd say, well, yeah, it looks like it's continuous, but I have to mathematically defend that answer. So I'm going to go through my checklist here. All right, we're going to start with looking at the limit as x approaches -4 from the left. So if I'm looking at the limit as x approaches -4 from the left, I would say, oh, okay, that looks like it's going to be 0. And then I would say, okay, now look at the limit as x approaches -4 from the right. So as I approach -4 from the right, oh, that also looks like it's 0. Now, because those are the same, I can say, so it can be determined that my overall limit as x approaches 4 actually exists and is equal to 4. Now, if we got two different answers here, you know, if this was 2 and this was 5, then we would say it does not exist. Okay, finally, it can be seen that f of -4. So I'm going to actually go to my graph and I'm going to evaluate my output when x is exactly -4. In this case, that is 0 as well. So because all of these numbers that we have written are the same, everything here that I've written, look at all 4, 1, 2, 3, and 4. Because all of those are the same, I can actually then state that this function is continuous at x equals -4 because, and here's what I would do. The limit as x approaches -4 does not exist. Well, we said it did exist, so it's not that one. The limit as x approaches -4 is equal to -4. That's true. Or the limit as x approaches -4 exists, but is not equal to f of -4. That's not true. So if it is actually continuous, it's going to be this middle choice here. The limit as x approaches -4 is the same as the function's value at -4. Okay, let's try the second one. So I'll just have to scroll up and down here. So this time we're looking at when x approaches, or when x is equal to 3. We want to test our continuity here. So the first thing I need to look at is what is the limit as x approaches 3 from the left and the limit as x approaches 3 from the right. So let's go back up to our graph here and look at the limit as x approaches 3 from the left and the limit as x approaches 3 from the right. So looking at my graph, as I approach, 3 is right here. As I approach 3, I would be able to say it kind of looks like I'm going to get an output of 2. That's approaching 3 from the left. As I approach 3 from the right, oh, look at that. It also, if I were to make an educated guess, looks like I'm going to get x equal or y equals 2 as well. So let's go down here and fill that in. So I said when x approaches 3 from the left, it looks like it's going to be 2. When x approaches 3 from the right, also looks like it's going to be 2. Now, because of that, it can be determined, that the limit as x approaches 3 of that function does actually exist. So it exists and it's equal to 2. Okay, finally, we have to figure out what is f of 3. So I'm going to go back up to my graph and I'm going to say when x is exactly 3, when x is exactly 3, what is my output? Now I see an open circle here, so you might be quick to say, well, it's undefined. However, don't forget, you need to look all over for x equals 3, and we actually do have a closed circle here. It looks like that output is -1. So let's go ahead and fill that in. So when f of 3 is -1. Now what I do is I look at all those values I just filled in. Okay, so this one, this one, this one, and this one. If they're all the same, then I can say that my function is continuous. Okay, but because there's one value that's different, I'm going to say it's not continuous. And I say it's not continuous, and I have 3 choices. It's not continuous because, let's see, the limit as x approaches 3 does not exist. Well, we just said that the limit as x approaches 3 does exist, so it's not this first choice. The limit as x approaches 3 is equal to f of 3. Well, here's the limit as x approaches 3, and here's f of 3. They're not the same, so it's not this one. The limit as x approaches 3 exists, but is not equal to f of 3. Okay, that's true. The limit as x approaches 3 exists, it's 2, but it's not the same as f of 3, which is -1. So what I would say is that this function is not continuous because the limit as x approaches 3 exists, but is not equal to f of 3. Okay, good work, guys. See you in classroom.